Hi, I'm Jim Heffron. These are my lessons in Calculus 1. So we're doing the homework now for section 4.1. So we're starting in on chapter 4, and we're getting to see the applications of the ideas and the techniques that we've been working on. So very exciting. Okay, let's start in here. Let's see. The very first problem, as almost always, is going back to a previous section and having a whack at it. So let's see if we can figure out what number it is. 65 in section 3.6. So the only way to keep it fresh in your mind is to keep going back at it. So let's see. There we go. Okay, and it's a 65. Oh, I didn't quite make it. 65, there we go. So I have to take the derivative of the arctan of the square root of x minus 1. Okay, so I gotta do the arctan of the square root of x minus 1. So I'm taking, it's x, right? X. It's the derivative of the arctan of the square root of x minus 1. So this is one of these three deep chain rules. So a person has to remember the derivative of arctan. It's 1 over 1 plus the thing squared. The thing happens to be the square root of x minus 1. That then, working with the chain rule, then we're going on to take the derivative of a 1/2 power. Derivative of a 1/2 power is 1/2 times the thing to the minus 1/2 power. And we've seen so many of them that I think a person can reasonably expect to remember. And not done, still have to take the derivative of the x minus 1. Okay? Okay, all right, so obviously, you can combine these into a single fraction, but basically we're done. Okay, great. Next up is to work on the section that we're working on, section 4.1, and there are two kinds of problems. Let's see here. Go to my. It's number 29 and oh, I made it. Okay, 29 and 37. So it says find the critical numbers of the function. So two different functions. The first function is f of x is 3x squared minus x minus 2. Minus x, plus x minus 2. All right, and I have to take the derivative and worry about where is the derivative undefined, where is the derivative equal to 0. So f prime of x is 6x plus 1. And where is it undefined? And the answer is never undefined. It's always defined. And where 0? And the answer is where 6x plus 1 is equal to 6x plus 1 equals 0. So x is minus 1/6. Okay, so that's the only critical number. Next up is number 37, which is p of x equals, it is x squared plus 2 in the numerator, and in the denominator is 2x minus 1. So the derivative, p prime, is going to be 2x minus 1 squared, 2x minus 1 times 2x minus x squared plus 2 times 2. Okay, so then I need to figure out what's happening. 2x minus 1 quantity squared, and here I have 4x squared minus 2x. Take away here 2x squared and minus 4. Okay, so then I got to simplify that. I'm looking at 2x minus 1 squared on the bottom. There's a 4x squared and a minus 2x squared, so I've got 2x squared. there's a minus 2x, and there's a minus 4. 2 times x squared minus x minus 2 okay, and x squared minus x minus 2 is going to factor into x squared minus x minus 2 is going to factor in x minus 2 and x plus 1. Whoops. So the sun has apparently decided to come out. Since it's never sunny here, I'm a little surprised, but okay. There we go. Maybe that's a little bit better. Okay, so we're looking at stationary numbers, that is to say critical numbers where the derivative is 0 at x equals 2, x equals minus 1. And also where 2x minus 1 equals 0. Those are the critical numbers where the derivative is undefined. So 2x equals 1, so x equals 1/2. Okay? Okay, then two more problems, 53 and 57. Those are a different kind of problem. In those problems, what we're trying to do here is to find the, I didn't quite get the direct, there we go. Find the absolute max and absolute min on the given interval. So it is number 53 and number 57. 53 is a polynomial. Of course, you notice that it's a closed and bounded interval. And 57, also a closed and bounded interval. That says 0.2. And f of x is some kind of rational function by the time you got a common denominator. Okay, so let's try a fresh piece of paper. See how we do with the first one. Again, really, it's almost never sunny here in December, so that's the way it goes, I guess. So 53. 53, we're looking at 2x cubed minus 3x squared. F of x is 2x cubed minus 3x squared. Minus 12x plus 1. And we're looking at negative 2 to positive 3. Negative 2 to positive 3 for the interval. I think I'm going to have to close that even some more. So let's see. Excuse me. Okay, sorry about that. So let's see. The derivative is f prime of x is 6x squared minus 6x minus 12. So that's 6 times x squared minus x minus 2. And obviously factors into 6 times, I think it's x minus 2 and x plus 1. Just by coincidence, the same factoring as the last problem that I did. So I'm looking here at the critical, the places, the stationary numbers are the places where the derivative is equal to 0, are x equals 2 and x equals minus 1. Okay, so I make up a table. That table is going to consist of the endpoints and also the 2 and the minus 1. So let's see, minus 2, minus 1, 2, and 3. And all I got to do is find f of x here, and that is to say simply plug into the function f and make up the table, and I'm done. So let's see, I guess this is minus 3. I did these in advance. This is 8. The 2 is a minus 19, and the 3 is minus 8. Okay, so the maximum is associated with the minus 1, and the minimum is associated with the minus 19. So the absolute maximum and the absolute minimum. Okay, so the absolute maximum is associated with the critical number -1. The absolute minimum is associated with the critical number 2. One of them's an endpoint, one of them is not. Okay, great. That was 53. And the last one is 57. So let's see. F of x is x plus 1 over x. And the interval for 57 is 0.2, that is to say 1/5, and 4. Okay, again, closed and bounded. I'm going to take the derivative, so f prime of x is 1 plus, and of course this is x to the -1 power, so you take the derivative, you get minus x to the -2 power. I'm going to get a common denominator, that kind of stuff. So I guess I'm looking here at x squared over x squared minus 1 over x squared. And so that's x squared minus 1 over x squared. And clearly what I've got here for places where this is x minus 1 times x plus 1 over x squared. So clearly what I've got for places where the derivative is 0 are plus and minus 1, and where the derivative is undefined is at x equals 0. Okay, so I'm ready for the table. Yeah, there we go. So this is x and f of x. Now I said that the derivative is undefined at 0, but 0 is not in the region of interest, so I don't have to include it in the table. I also said that the derivative is equal to 0 when x is minus 1, but minus 1 is not in the region of interest, so I'm not going to include it in the table. So the only things that get put in the table is 0.2, positive 1, and positive 4. And then again, I did this in advance. Let me find the darn thing. What I do with it? What I do with it? So 0.2 is 5.2. 1 is 2, and 4 is 4 1/4, 4.25. Okay, so I'm looking at the maximum is the biggest one, so that's the max, absolute maximum, and the minimum is the smallest one, so that's the minimum. Okay, so we've done a problem here where it so happens that some of the critical numbers don't need to go into the table because they just simply don't apply. They're not in the region that we've declared an interest in. Okay, very good, very good. So so this is a section that it seems to me is obviously of practical value. So that's nice. Okay, great.